We will now see how we can read data from Monet database. And before that, I will first create two sample tables. I will create a table with the name employees, which has two columns, employee ID and employee. And then I will fill this table with data. I will place these 4 rows in this table. And then I will create table with the name sales. So this is creation of a table sales. And in this table, I will place 6 rows of data. Now that we have our tables ready, I will now clear my screen. We will now start reading from our tables. And for start, we will use the simplest select statement. And this statement will give us all of the rows and columns from employees table. When we are using star, that means that we want all of the columns, and we didn't express any filter on this table, so we would get all of the rows. Now, if we want to get only some of the columns, then we have to give names of those columns. And here, I first named our employee ID column, and then employee column, and also I created an alias for this employee column, which will be renamed to name column. So when we run this, we will get the same result, but this time we explicitly said what columns we want to get, and we also renamed this employee column. Now, we don't need tables to use select statement. It is also possible to use select statement with some expressions. Here I have 2 expressions, 3 plus 3, and we have a function current date. So when we run this, we will still get a result. We have our result, 6th and current date. We don't have names for our columns, so we are using just default names, and we are not using any table for this select statement. But we can, if we want to, we can combine in select statement values from some table. For example, from table employees, we can read the column employee, and we can also have a column which will contain current date. So if we run this first column is from our table, but this second column is created by an expression. Now, the column can be part of the expression. So we can, for example, multiply employee ID with 11, and our result will be named as a column multiplication. Notice that I have used double quotes around multiplication. So when I run this, the result is, of course, 1 times 11, 2 times 11, and so on. But notice that this column has a name with the upper letter as a first letter. And this is the consequence because of that we have used double quotes. Now, if we don't use double quotes around some identifier, in that case, everything will be transformed to small letters. I will now clear my screen. I want to explain something concerning those double quotes. If we create a new table and we use name of a column that is delimited with double quotes, this will work. We will create a normal table. But after, if we try to read from this table with this statement, where we don't have double quotes around column name, we would get an error. And this is because when we are using double quotes, Monet is expecting exact case for this word. But when we are not using double quotes, Monet will transform every word to lowercase. And because he's expecting exact match, he will say, well, this is in lowercase, this is in uppercase, and these are not the same words. So he will say that this is an error. And if we want to make this statement to work, then we have to use double quotes in the select statement. So this will be correct syntax in this case. I will now clear my screen. If we want to filter data from our table, in that case, we have to add where close to our select statement. So if we use a statement like this one, where we are saying that employee ID should be equal or bigger than number 3, we wouldn't get employee IDs where number is 1 or 2. We would only get 3 and 4. So this is how we make a filter. We can reference any column inside of our filter, and this expression can be much more complex. Here we just use a really simple expression. Beside using where we can also use order by. When Monet is returning data, he is returning data in a way that will have the biggest performance. So Monet will not guarantee any kind of order in our data, but if we want our data to be sorted, then we have to use order by clause. So we have to be specific, and we can order by employee ID column first in descending order. So we have this 3, 3, 3, and at the end we have 2, 2, 2. And then we can order by quantity. And if we don't specify this word ascending, that means that quantity will be ordered in ascending order. So inside of 3, we have this order 20, 40, 60. And inside of 2, we have this order 10, 30, 15. So we have ascending order. And we can notice that it is important in which sequence we list our columns inside of order by clause. If we switch quantity and employee ID, then order will be different. Then there is another way how we can control number of rows from our table. Let's say that our table, these sales, have these 6 rows. But if we add the keyword distinct, like this one, then we would only get distinct values. So this is the same statement, just we added distinct here, and in this case we would get only different values. We have 3 different values, so we get only 3 rows. Now, if we want to limit number of rows that is returned by select, in that case we use keywords limit and offset. So something like this. And what does this mean? Well, limit 2 means that we are going to read only 2 rows, and offset 1 means that we will skip the first row. So we will skip the employee ID first one because we order by employee ID. So without limited offset, we would get all of the employees, employee ID 1, 2, 3, and 4. But with offset 1, we will exclude first employee, and then we would read the next 2 employees. So we would read only employees Gabriel and Aurora. Then we can use the limit and offset just by themselves, so we don't have to combine them. If we just have this statement limit 2, in that case we would read the first 2 values. And if we use just offset, in that case we would read everything except the first 2 rows, because we would skip first 2 rows and then we would read everything else. But with limit 2 we would read only first 2 rows. I will now clean my screen. I will now show you how to group values in select statement. So I will use this select statement here. And at the end of this select statement, I have this group by clause. So if I run this, I would actually just get distinct values for these 2 columns. And it is the same thing that I could get with a distinct keyword. But group by is actually used for something more powerful. So we have to use another example to show you that. I will run this. And now we have a summary of our table. Now imagine that our table is really big with a lot of columns, but we can summarize that table to only these 2 columns that will define a group. So we have a group where employee ID is 2, and we are using this date where employee ID is 3, and we are using, so these are definitions of a group. We are grouping to all of the distinct values for date column and employee ID, and then we are aggregating quantity for those groups. And this is the power of group by clause. I will now clean my screen. If we want to group by expression, then we have to give an alias to that expression and then to group by that alias. So if I run this, this is how we can group by our expression, because 2 times 3 is 6. Next, I will show you how we can select from hard-coded values. And for that, we will use this values clause, and then we will provide our values. So if I run this, I will get 2 columns and 4 rows. It is also possible to give names to these columns, and for that I will use this statement here. So I will say as, and then table name, and then name of my columns. So we can also give a name to this new table. So if I run this, this would be the result. We have columns number and word.